Did Voyager 1 really turn around out there in the dark, or did it stumble into something so strange that even now we still do not know what it means? Because the truth is more unsettling than the headline. The oldest explorer humanity ever built is still whispering from beyond the sun's protective bubble, and some of what it hears should not be there. If you love space stories that make the universe feel bigger and your place in it feel smaller, take 1 second to like this video, subscribe, and share it with one person who still looks up at the night sky and wonders what's waiting out there. First, let's clear up the part that sounds impossible. Voyager 1 did not suddenly spin around like a lost car, making a U-turn in deep space. It is not racing back toward us. It is still moving outward, farther from Earth every hour. But during the way it points, rolls, and keeps itself communicating with home, it continues to sense the space around it. And what it has found in that space is the real story. The real story is that Voyager 1 has gone so far and lasted so long that it is no longer just a spacecraft. It is our only live microphone in interstellar space, not near Earth, not near Mars, not even at the outer planets. It is beyond the heliosphere, beyond the giant bubble blown by the sun, out in the region between stars. And while it drifts through that darkness, it keeps sending us clues about a place no human has ever visited, and no telescope on Earth can sample directly from the inside. That is what makes this story powerful. It is not only about distance, it is about access. We can look at galaxies through giant telescopes, we can model plasma with equations, we can simulate magnetic fields on supercomputers. But there are still some questions that refuse to answer themselves from far away. For those questions, you need a witness. Voyager 1 is that witness, and it was never supposed to become one. When Voyager 1 launched in September of 1977, NASA did not send it out to solve the deepest mysteries of interstellar space. The mission was bold, but it was focused. Fly by Jupiter, fly by Saturn, take measurements, capture images, expand what humanity knows about the outer solar system. If everything went well, the mission would still be remembered as a success. Then everything went better than anyone had a right to expect. At Jupiter, Voyager 1 did not just take pictures. It found a faint ring around the planet, discovered 2 small moons, Thebe and Metis. At Saturn, it found 5 new moons and a new ring. It revealed worlds that had never been seen up close before. It gave scientists fresh data, fresh beauty, and fresh reasons to realize that the solar system was wilder than the textbooks had promised. But the deeper miracle was not what it saw at Jupiter and Saturn. The deeper miracle was that it kept going. Year after year, decade after decade, Voyager 1 stayed alive. Governments changed. Computers shrank from room-sized machines to the phones in our pockets. Entire generations were born, grew up, and entered research labs, while this probe just kept moving outward. Think about that. There are scientists studying Voyager data today who were not alive when Voyager left Earth. Some of their parents may not even have met yet. And still, the signal kept coming. That signal matters because of one invisible thing, the heliosphere. If you want to picture it, imagine the sun not only as a bright ball of light, but as a machine constantly blowing a stream of charged particles in all directions. That flow is called the solar wind. It pushes outward and creates a huge magnetic and particle bubble around the solar system. Inside that bubble are the planets, the moons, the asteroids, the comets, and every human being who has ever lived. The outer edge of that bubble is called the Heliopause. It is where the sun's outward pressure finally loses the fight against the interstellar medium beyond it. Inside the heliosphere, the sun still dominates. Outside it, interstellar space takes over. That boundary matters for a reason that is easy to miss. The heliosphere is not just a line on a chart. It acts like a shield. It helps reduce the amount of dangerous galactic cosmic radiation that reaches the inner solar system. It is not a perfect shield, but it is protection. So when Voyager 1 crossed the Heliopause in August 2012 and became the first human-made object to enter interstellar space, it did more than break a record. It crossed the edge of our local shelter. And that is where this story starts to feel different. For years, people imagined interstellar space as a kind of silent emptiness, cold, thin, almost featureless. Not literally nothing, but close enough that our minds could treat it like a giant cosmic blank page. That picture made sense from a distance. When you have never put an instrument inside a place, you fill the gaps with theory and inference. Then Voyager 1 got there, and the blank page began to answer back. One of the most important surprises came from its plasma wave instrument. Scientists studying the data found something faint, narrow, and persistent. A steady hum in the interstellar plasma. Not a loud blast, not a dramatic one-time spike. More like a low, continuous note. A signal so subtle that it would have been easy to miss if nobody had the patience to keep listening. That hum mattered because earlier plasma measurements from Voyager often depended on bursts caused by solar eruptions. A solar event would send a disturbance outward, and the spacecraft could detect how the surrounding medium responded. Useful, yes, but scattered. Like trying to understand an ocean by waiting for a few storms. This was different. The hum suggested that interstellar space was not just waiting around in silence until the sun kicked it. It had its own low-level structure and motion. It had density that could be tracked more continuously. It had texture. The region between stars was not turning out to be empty in the way people casually imagine emptiness. It was active. Subtle, but active. That may sound like a small correction. It is not. Because the moment you learn that a place has structure, you stop thinking of it as background and start thinking of it as an environment. And environments have behavior. They change, they interact, they press back. That matters to physics, because our models of the heliosphere depend on what is outside it. It matters to future exploration, because any spacecraft that goes farther will travel through that environment. And it matters to life on Earth in a long-range way, because the shape and strength of the heliosphere are tied to the interstellar conditions surrounding it. In plain English, Voyager 1 is helping answer a very old human question in a very modern scientific form. What exactly is out there, and how much does it affect us even when we cannot see it? Now here is where the tension gets sharper. The hum itself is still not fully settled. Scientists have strong ideas about what causes it. One explanation points to persistent plasma oscillations. Another points to quasi-thermal noise. Those are technical phrases, but the important part is simple. The data is real, the signal is there, and the full explanation is still being worked out. That is the kind of mystery science actually lives on. Not magic, not fantasy. A real phenomenon, measured by a real instrument, waiting for better understanding. And while Voyager 1 was giving us that mystery, the spacecraft itself was becoming one. In late 2023, something went wrong. Voyager 1 was still sending a radio signal to Earth, which meant it was not dead. But the data arriving from the spacecraft stopped making sense. Engineers were getting unreadable information. The probe was talking, but it sounded like nonsense. Imagine the feeling in that room. A machine built in the 1970s, more than 15 billion miles away, still alive after nearly half a century, suddenly speaking in a language its own team could not understand. This was not a problem you could solve with a quick reset. Signals take about 22 and a half hours to reach Voyager 1, and another 22 and a half hours to return. Every test required almost 2 full days just to complete one loop of communication. Ask one question. Wait. Receive one answer. Ask another question. Wait again. That delay changes everything. On Earth, when a system fails, engineers can poke at it fast. They can try 5 ideas before lunch. With Voyager 1, one wrong move can cost days. A risky move can cost the mission. Eventually, NASA engineers isolated the trouble to corrupted memory inside one of Voyager 1's computers, the flight data subsystem. About 3% of its memory had been corrupted. The team believed a single chip storing part of that section had likely failed, either because it had been struck by an energetic particle or because it had simply worn out after 46 years. Just stop there for a moment. A single bad chip. Not a dramatic explosion, not a giant collision, not some movie-style disaster. A tiny failure inside ancient hardware, after decades in the harshest environment any human-made object has endured. That tiny failure was enough to threaten one of the greatest scientific missions in history, and the fix was extraordinary. Since they could not repair the bad hardware directly, engineers did something brilliantly human. They worked around it. They divided the affected code into sections, moved those sections to different places in memory, and adjusted them so they would still work together. They updated the references that told the system where to find them. In other words, they performed remote software surgery across billions of miles, with a round-trip delay longer than many international flights. If that level of patience impresses you, hit subscribe now and stay with this channel. Because stories like this prove science is not only about discoveries, it is also about stubborn people refusing to let a miracle go silent. When the changes started working in April 2024, Voyager 1 began sending readable engineering information again. Soon after, it returned science data from all 4 operating instruments. The ancient machine had not only survived, it had recovered. It had come back with its voice intact. That recovery changed the emotional center of the mission. Before the glitch, Voyager 1 felt old. After the glitch, it felt fragile. And fragile things make us pay attention in a new way. Suddenly, every new transmission felt less like routine data and more like borrowed time. That sense of borrowed time matters even more now, because Voyager 1 is running out of power. The spacecraft is powered by radioisotope thermoelectric generators. They turn heat from decaying plutonium into electricity. At launch, Voyager had far more power to work with than it does now. But these power systems weaken year by year. NASA says both Voyager spacecraft lose about 4 watts of power every year. That may not sound like much on Earth. Out there, it is everything. When your power margin is thin, every watt becomes a decision. Keep one heater on, and maybe another component has to go dark. Keep one science instrument alive, and maybe you shorten the mission by months. This is not only engineering anymore, it is triage. In April 2026, NASA shut down Voyager 1's low-energy charged particles experiment to save power. That was not because the instrument had stopped being valuable. It was because the mission had reached the stage where survival itself had become a technical balancing act. After that shutdown, Voyager 1 was left with 2 operating science instruments, one measuring magnetic fields and one listening to plasma waves. Think about the emotional weight of that. A spacecraft launched with a full suite of tools is now crossing interstellar space with only a few senses left. It is like an aging explorer still walking into unknown country with a dim flashlight and a notebook, writing down whatever can still be seen before the battery fades. And even here, NASA is not done fighting for more time. Engineers have been working on an energy-saving strategy nicknamed the Big Bang. The idea is to rework how powered devices are used, replacing some with lower power alternatives and trying to stretch the remaining life of the mission. Voyager 2 is the safer spacecraft to test the plan on first because it has a little more power to spare and is closer to Earth. If the tests work, the same strategy may be used on Voyager 1. There is even a chance it could someday allow the low-energy instrument to come back on. That possibility matters, because every extra month Voyager 1 stays scientifically alive is priceless. There is no backup probe already sitting at the Heliopause waiting to continue the job. There is no second live laboratory drifting through the same region with fresh instruments ready to take over tomorrow. Right now, humanity has one active listener in interstellar space, and that listener is nearly 50 years old. This is also where the title starts to feel almost poetic. Voyager 1 did not turn around in the literal sense, but in another sense, it did something even more powerful. It turned our attention around. It forced us to look again at assumptions we thought were settled. It took a region of space that many people treated like empty black wallpaper and made it real. Not as scenery, but as a physical place with density, magnetic behavior, plasma structure, and unanswered questions. That is what great missions do. They do not just go far. They make old ideas feel too small. And the next milestone will make that feeling even stronger. NASA says Voyager 1 is on track to become the first human-made object to reach a distance of 1 light day from Earth on November 18th, 2026. Think about what that means in ordinary human terms. Light is the fastest thing we know. If you send a signal to Voyager 1 at that point, it will take a full 24 hours just to get there. 1 day for the message to arrive, another day for a reply to come back, 2 days for one exchange. That is not just distance, that is loneliness measured in physics. No human-made object has ever operated that far away while still speaking to home. And Voyager 1 is not reaching that distance as a dead relic. It is reaching it while still doing science. Let that sink in. A machine built when disco was on the radio and most of the internet did not even exist is moving toward a point where light itself needs a day to catch it. Yet we still hear from it. We still learn from it. We still depend on its readings to tell us what the space beyond our protective bubble is actually like. Voyager 1 is not just far away. It is redefining what far away even means for our species. Now I want to slow down and ask the deeper question behind all of this. Why do people care so much about a small machine drifting through darkness? Part of the answer is obvious. It is a triumph of engineering. It is a story of human skill, patience, and endurance. But that is not the whole answer. The deeper reason is that Voyager 1 touches a nerve that most of us carry quietly. We want proof that reaching beyond our current limits is worth it. We live inside routines, bills, deadlines, stress, bad news, small arguments, long commutes. Most days our lives are measured in rooms, roads, and screens. Then, a story like Voyager 1 crashes through all of that and reminds us that human beings are strange. We are the kind of species that learn to shape metal, harness physics, and throw a device into the dark just to find out what the dark was hiding. That is not practical in the everyday sense. It is bigger than practical. It is civilizational. Voyager 1 also matters because it makes humility unavoidable. For a long time, we could talk about the space between stars as if we had a decent grasp of it, but the moment an instrument actually entered that region and started sending back direct measurements, our confidence had to shrink. Science is not ignorance dressed up as certainty. But reality always has the right to be more detailed than our expectations. That is one of the healthiest lessons in all of science. The universe is under no duty to match our first draft. And Voyager keeps proving that lesson in a way that feels almost personal. It crossed the Heliopause and the story became more complicated. It listened to the plasma around it, and the emptiness turned out to have a voice. It nearly lost contact, and engineers found a way to bring meaning back out of the noise. It began running low on power, and instead of giving up, the team started making painful decisions to protect the final years of discovery. Every chapter pushes the same idea. The farther you go, the less simple the universe becomes. There's a haunting beauty in the timing of this mission. Voyager 1 is exploring interstellar space at the exact moment when humanity is more connected than ever, yet often more distracted than ever. We can scroll past almost any fact in seconds. We can absorb astonishing information and forget it by dinner. But Voyager 1 resists that kind of shallow attention. Its story asks for patience. Its signal arrives slowly. Its mysteries unfold slowly. Its meaning builds slowly. Maybe that is part of why it feels so moving. Voyager 1 is a slow message in a fast age. And then there is the golden record. Bolted to the spacecraft is a gold-plated record carrying sounds and greetings from Earth, human voices, music, the sound of our planet. It is one of the most emotional objects we have ever launched into space because it says something very simple. If someone finds this, we want it to be known. On one side of the mission, precise measurements of plasma waves and magnetic fields. On the other side, a bottle in the cosmic ocean carrying laughter and song. That is humanity in one image. We want to understand the universe, and we want to be understood by it. Even if nobody ever finds the record, the gesture matters. It tells us who we were when we first reached this far. Curious enough to ask, hopeful enough to answer, and bold enough to believe a message from Earth belonged among the stars. But now we come to the hardest part of the story. Voyager 1 will not last forever. Sometime in the early 2030s, if current trends hold, the spacecraft will finally run out of enough power to keep even its last science instruments alive. One by one, systems will fall silent. One day, the final useful signal will begin its long trip home. It will cross billions of miles, it will reach Earth, engineers will record it. And after that, there may be nothing more. No dramatic explosion, no final speech, just silence. That future silence gives everything Voyager does right now an almost heartbreaking value. Every measurement matters because it may be the last of its kind for a long time. There is no funded mission ready to arrive at interstellar space in the near future and continue real-time sampling where Voyager leaves off. If this window closes, it may stay closed for decades. That means the unanswered questions may remain unanswered for a generation. What exactly is producing the persistent plasma signal? How does interstellar weather shape the heliosphere over long periods? What other structures or variations are waiting farther out? How strange is the environment once you stop treating it as empty and start measuring it closely? Voyager 1 may not solve all of that before it goes quiet. But maybe that is not failure. Maybe that is the purest kind of success. Not finishing the map, but proving the map is worth drawing. If this kind of deep space truth is why you watch, stay close to the channel. Subscribe. Share this with someone who loves big ideas. And tell me in the comments the moment that hit you hardest. Because the next frontier story will matter even more if we keep exploring it together. Because once humanity knows a frontier is real, it becomes very hard to ignore. Someday we will send better instruments. Someday we will build spacecraft designed from the start for the interstellar medium. Someday we may cross that boundary with missions that learn faster, travel farther, and answer the questions Voyager could only raise. But when that day comes, those missions will not begin the story. They will continue one. They will continue the story of a spacecraft launched in 1977, powered by decaying plutonium, built with old hardware, patched across impossible distances, still whispering from beyond the sun's last great border. And that brings us back to the opening question. Did Voyager 1 turn around and find something we cannot explain? Not in the literal sense. The spacecraft is still moving outward. But in the deeper sense, yes, it turned our certainty around. It made us face how much of the local universe we still do not fully understand. It found a persistent interstellar signal that scientists are still working to explain. It revealed that space is not dead, not simple, and not silent. That is the real discovery. Not a neat answer, but a harder question. Not closure, but contact. Not the end of exploration, but proof that exploration still has the power to surprise us. And maybe that is why Voyager 1 matters so much. Because in an age when people act as if everything has been found, this machine proves the opposite. There are still edges. There are still mysteries. There are still places where the data arrives, and the response is, we are not finished learning how to understand this. Right now, as this video ends, Voyager 1 is still out there. Still moving, still aging, still sending. A nearly 50-year-old explorer in a realm no human being has ever touched, measuring a place we once treated as emptiness, turning it into reality one faint signal at a time. One day the signal will stop, but the meaning of it will not. Because long after the last transmission fades, Voyager 1 will keep going, past our attention, past our lifetimes, past the memory of the news cycle, carrying our science, our curiosity, and the sound of who we were into the dark between the stars. And maybe the most beautiful part of all is this. Even now, with power fading and time running short, it is still teaching us that the unknown is not a wall. It is an invitation.